All right, in this video, I want to talk about two other tools of monetary policy available to the Fed. So to start with here, let's look at the discount rate, which is one tool that the Fed can use to try to influence the amount of lending and the equilibrium rate in the federal funds market. So to start things off, let's assume that currently in the market for reserves that the federal funds rate is somewhere below the discount rate. Okay, so that's one setup. What that means is that if I graph my market for reserves, I have something like this. Supplies here, interest rate on the vertical axis. IFF is less than ID just means that the demand curve should intersect the supply curve somewhere like here, where IFF is down below the discount rate, and the discount rate is just always where the supply curve levels off. So how does this tool work? The discount rate, ID, is the interest rate that the Fed charges on discount loans. These are loans that go directly from the Fed to commercial banks. Commercial banks will sometimes approach the Fed and they need reserves. So one way to get that is to ask them for a discount loan. They take out money, the commercial bank takes out the money, borrowing it from the Fed, and the interest rate they owe on the loan is just measured as ID. All right, so just to put some numbers down here, right, like this could be like a 6% as an example, right? IFF is somewhere down below that, so I can make that one like 3.5%. Okay, so suppose I'm in a situation like this. How does discount rate work? One option is to lower the discount rate, so lower ID. If I lower ID, that just means I'm dropping the discount rate from 6% to something less. So sometimes you'll be asked, what happens in the market here if I lower the discount rate? Or another way to put it is, suppose in the market for reserves, the equilibrium rate is this IFF 3.5. Can the Fed lower the equilibrium rate by changing the discount rate? So how would I figure that out? What I need to do is just drop ID down. So if I drop ID from 6% to something below, then I'm just going to have the supply curve level off at a new place. So notice, if I'm not very ambitious, right, like I lower the discount rate maybe to 5%, then the supply curve would only level off at a place like this. All right, at 5%, I'm somewhere above 3.5 and below 6. Notice if that's all I do, then the equilibrium rate stays at 3.5. That is, the supply curve intersects the demand curve at the same point. The only way I'm going to be able to lower the equilibrium rate is to drop that horizontal part of supply somewhere down below this, 3.5. Like say I push it all the way down here. So I do a big drop in the discount rate, something like that. This here now, of course, is just somewhere below 3.5, like maybe 3%. So if I lower the discount rate significantly, then if I look at the new supply curve, which again I'm going to sort of highlight here, so it's that part and then this part. And the rest of this supply curve has all disappeared. The demand curve hasn't budged. So now you can see that the supply curve and the demand curve intersect at this point, that 3%. So with a significant lowering of the discount rate, I can actually drop or decrease the equilibrium rate paid for reserves. All right, let's do one other graph here where in this case, what happens if I raise the discount rate? So suppose I have something like this, supply. Again, I'm going to do a demand curve here. So IFF is less than ID. Okay, so that's my initial setup. That's sort of one possibility on how the market can look at a certain point in time. IFF is here. All right, so IFF is less than ID in the current market for reserves. And then I ask, what happens if the Fed raises the discount rate? What I'm curious about is What's going to happen to the equilibrium rate if the Fed raises the discount rate? The discount rate is essentially the horizontal part of the supply curve. It's where the supply curve levels off. So like before here, we said it's like 6%. If I raise the discount rate, instead of 6%, it just becomes something higher up here on the vertical axis. So we go from like 6% to, again, I'm just making up a number, maybe like 7%. So I regraph supply. So supply has that vertical part here. Instead of stopping at 6, I just go up to this new point and level off there. So this is like S2. Essentially what happens is when the Fed raises the discount rate, they're controlling the horizontal part of the supply curve. That is, this shifts up as opposed to shifting down. Okay, this disappears. What happens to my new equilibrium rate? Well, let's see. The initial equilibrium rate was here. After I shift up this horizontal part of the supply curve, the new equilibrium rate is just right where it started. That is, the demand curve intersects the supply curve at the same place. That is, in this case, there's no change in the equilibrium rate.